So good morning, dear students. So we are set to start today's class. Okay, good. I think all of you have logged in, yeah, as given in the instructions. Yeah. So Deepak at symbol is missing. Okay. Lavanya, your USN is missing. Okay. I just want to check whether you people are following the protocol. This is a protocol, and in this recorded video, we have to upload it to university portal also. So that is the requirement. It's a requirement. We'll start today's class. It is good to go. Good morning. So more than 50% of the class is present. So my duty is to start, class on time. Okay. So in lab 3 of part B, so that is what we are going to discuss today according to the agenda that is earlier announced. So you have to study the transmission of packets over Ethernet. So you have to create an Ethernet LAN and you have to study the transmission of packets. Determine the number of packets dropped at the destination. So we have to find number of packets dropped at the destination. So what you'll do, if the Ethernet is perfect Ethernet, what happens? There will not be any packet drop. So what we'll do, purposefully we create some error. We'll inject some error, and once the error is injected, automatically the packets will drop. So we'll find out how many packets got dropped, and we'll plot a graph against the number of packets dropped and the time at which the packets got dropped. So first we'll create a NS object. So network simulator object. Later NAM file is created and we open it with lab3.nam with W write mode, and we'll trace all the NAM files, NAM trace, and we'll create a trace file. We'll also record all the tracing happening in that trace file. Later, we set the TCP packet size, agent / TCP packet size. We set it to 1460. So this is just for the standard. Ethernet follows 1460. So we certainly set the packet size. So why this packet size is set? Because we are using Ethernet LAN protocol. So since we are using Ethernet LAN protocol, so it is required that we have to set the packet size later. So we create for 5 nodes, N0, N1, N2, N3, N4. We create 4 nodes, and once we create the 4 nodes, so what happens? So there is a link between N0 and N1. So there is a link between N0 and N1. We'll discuss that how exactly it will have N0 to N1. There is a link. So virtually I'll just write a diagram so that we will have okay. So N0 to N1. So there is a connection. There is a connectivity. There is a link. Okay, there is a link between N0 to N1. So probably this is we call it as 1, and probably this I'll call it as 2. So I'll just write it as 2. So I'll just write it as 2. Yes. So there is a link between N0 to N1, and its bandwidth is 1 Mbps. So you can see there is a 1 Mbps bandwidth. So you can see 1 Mbps. So 1 Mbps is the bandwidth. So that is between these two, and of course it is done. Further, so we'll create another link. This link between N1 to N2. Of course, you observe here. So N1 to N2, and uh, it is again what we call it as. So it is again what we call it as a link. It's a link between. Okay, so this is 0, 0 to 1 is also 1 Mbps, 1 to 2 is also 1 Mbps, right? Further, uh, we create a LAN. Further, we make a LAN. You can see, sorry. Further, we make a LAN. So what we'll do, this LAN is between N2, N3 and N4. So you create a LAN. So you create a LAN. Okay. So this is a LAN. Of course, I'll just for the sake of or this one, I create it as LAN is created as you know Ethernet LAN is created as what, and it is composed of N2, N3, and N4. So N2 is connected to LAN, and N3 and N4 are also connected. So you can think of nodes connecting like this. So N2 and N3, yes, N2 is connected, N3 is connected, so N3 is connected, and N4. So N2, N3, N4 are connected, and it is forming a Ethernet LAN, which is of, observe here, it is 100 Mbps. So this line is actually 100 Mbps. So it is 100 Mbps, which is very much high speed. So this is very low speed, 1 Mbps. So between 1 and 2 and 0 and 1, there is only 1 Mbps. But the LAN that what we are seeing here, it is actually 100 Mbps, and which is using 1 millisecond of delay, and linked list. Queues are being used, and of course drop tail. So you have a drop tail, and it is following a protocol. It is following a protocol 802.3, so MAC. So it is following a protocol 802.3, and the channel is a physical wired channel. So these are the specifications that we have. These are the specifications that we have, and observe now. So once the LAN is created like this, 0, 1, 2, 3, 4. So 4 nodes are connected like this. This is normal connection, point-to-point link connection. This is actually Ethernet connection. Ethernet connection is having high bandwidth, and so purposefully we create error. So when this system is working without any errors, without any problem, so there will not be any packet drop. So what we'll do, we'll purposefully create error. Purposefully we create error. So we call it as error model, and the error model, we say it as rate is 0.2. That means every 100 seconds, 2 seconds, it will send error. So it will create error. So for every 100 packets, 2%, 0.2 means 2%. So will be errors, and error will be set. So, and what happens? So error is a random variable, and this happens at a random rate. So error, you cannot predict when it will happen. So error will happen at a random. So ran variable, we call it as, which is a new random variable, which is uniformly random variable, and target, we certainly, drop the packet at the agent null. Null we have not yet created. Null is, I think we know TCP is the source. Null is the destination. We already know from the lab 1. So you apply this error model at the, target. Target means the destination node. Okay, fine. So, and the loss model, this entire thing we call it as loss model, and error model will be working with node 0 and node 1. So node 1 to 2, there is an error. So always this error, always this error will happen. Always this error will happen in this range. So in this location, error will happen in this location. So between 1 and 2, error will happen, and packets will be dropped at the this one. Now we are creating a TCP agent. TCP we are creating next, and TCP we are attaching to N0. So TCP we attach to N0. So TCP we attach to N0. Fine, it is attached. Next, what we are doing next is next we are creating sink. So this is actually TCP source. Sink is attached, and sink is attached. Sink is nothing but it's the TCP destination, and it is attached to N4. So N4 is actually sink. So sink is actually N4, and it is attached to N4, right? And further, what we are doing, we are connecting the TCP and sink. So TCP is connected like this, like this, like this. It will go straight away to sink. Yes, it is going and it is reaching sink. Yes, that's fantastic. And when it goes to Ethernet, what happens? Ethernet is a shared link. So the packets will go to 3 also, the packet will go to 4 also. But we are addressing to packet number 4, that is node number 4. So only it reaches node number 4. Node 3 will never accept the packets because it is not addressed to this. So it will never accept the packets, right? Now, TCP cannot run on its own. It requires what do you call it as application layer protocol. Upon this TCP, we need a protocol that is FTP. FTP protocol is working on TCP. So it is working on TCP. So FTP we are creating, and once we are creating FTP, we are attaching on top of the TCP. Yes, and the file size we are setting. The file size here, it is 4 MB. The file size is 4 MB. Okay, fine. And file will be sent at 0.0 seconds, and FTP will send the file size, that is 4 MB file. It will send through this link, and it will reach the destination, that is 4. Fine. So that is the procedure. Now, what happens at the end? So what happens at the end? You create global variables, NS NAM file, trace file. You close, flush, close, trace you will stop. NAM file you close it, trace file also you close it. And you write a AWK code just to track how many packets have dropped. So you know very well, it is having, AWK code is having 3 portions: begin block, process block, and end block. In the begin block, we are not initializing anything. In the process block, what you are doing, you are writing. If $1 is nothing but the field in the trace file. If it is having the D component, D is nothing but drop, and the packet is TCP. So, and if it is greater than 1460, automatically what it will do, it will count the packet. So what is the number of packets? Count packet plus plus. It is counting the packet. And finally, it is writing $2 is nothing but time. time and the number of packets dropped into lab3.data. It is storing in lab3.data. It is just pouring it. And once this is done, so you are ending the entire procedure. Further, once the procedure is ended, so you execute the AWK code that you have written on lab3.tr, and what happens? You execute the NAM file so that the entire simulation works. Once the entire simulation works, you create a graph. You create a graph. So when you create a graph, so I think it is very clear. So when we create a graph, so BB means box, and TK, thick line. X-axis is equal to time, Y-axis is equal to dropped packets. So the graph will be plotted based on lab3.data with the background color as white, and it is running in the what you call ampersand. It is running in ampersand in the sense in the background. So entire this one is running in the background, right? So that is the concept. And finally you exit, you run the exactly this entire simulation runs for 100 seconds. So at the 100 second it will call finish, and finally you can run NS. When you run this NS, so what happens? How to run this NS? Very simple. $NS lab3.tcl. So the entire file, I just write it as lab3.tcl, and I just write it NS lab3.tcl. If I write it, so what happens? You will get the output like this. You observe here, 0, 1, 2 is there. 2 is connected to this, and there is a Ethernet line. For Ethernet line, you have connected lab program number, node 3 and node 4. So this is the source and this is the destination. So this entire line setup is actually what we call it as 1 Mbps bandwidth, whereas the data link, the Ethernet link is having bandwidth of 100 Mbps. It is very fast. So when we run this simulation, automatically what happens? Some packets will get dropped because we have introduced error model between 1 and 2. So between the links 1 and 2, we have introduced error model that we have seen, and due to that it is dropping the packets. And the entire dropping of packets we have collected. We have put in lab3.data, and based on lab3.data, we have plotted the graph like this. So lab3.data, you can observe the graph is being plotted based on this. So in the x-axis you have time, and in the y-axis you have number of packets dropped. And now we have to understand how many packets got dropped. We want to understand how many packets got dropped. So if you see the total number of lines in lab3.data, if you see the total number of lines in lab3.data, so you will get the total number of packets dropped. So for this, what I'll do, I'll give the command wc-l lab3.data. So I'll get 178. So totally 178 packets got dropped during the entire show. So that's all for this lab program. And the entire explanation to this lab program is available in this website, and lab program manual is available in this website. Thank you for watching this video, joining the class. So I think the CR now you can take the attendance. So you can give the attendance only to these people who have attended. So there are 31 students. So you can just consider that. You can give the attendance. So that's all for the day. Have a wonderful weekend. Thank you.
Guys, your name should be ahead of your USN. You should not put your name after the USN.
Yeah, I think you can observe. Is there anyone who has done? Okay. No, of course, now you have already logged in, no problem. For the next session, you can do the same thing. Name and at symbol and your USN. And kindly, based on this CR, please give the attendance. So that's all. Thank you for your cooperation. So have a wonderful weekend and happy learning. So that's all for today's class. On Monday, we'll start our new module. And before that, today itself I'll announce assignment on based on module 1 and module 2. What you have to do is you have to write in a book, and later using your mobile camera, you convert it into using CamScan or whatever app, convert it into PDF, and I'll give the link. You have to upload that assignment question answers to the question to that particular link, in that link. Okay, so all those instructions will be given to you very shortly. So try to work on it. And we have received a message from VC, Vice Chancellor, VTU. Once the lockdown is done, so in the month of June, you will have exams as usual. So there will not be any delay in the examination. So keep reading, keep prepare yourself. And so by that time, we start our class during the month of May first week. So we could able to complete module 3 or module 4, and we will have very less time to complete module 5, and we'll finish it as early as possible. And lab programs are also, you are supposed to work from home itself. So you have to execute these programs, you have to start practicing. So what we will do once we join the class, once the lockdown is open, so we will conduct internal tests. We'll do a lot of work will be there. Don't get pressurized by yourself. So try to prepare from now onwards. And you have given me very good results in first semester Unix 100% result. I should be thankful to you. Hope I'll expect the same from you in CN also, computer networks also. So that's all for today's class. I'll be announcing assignment today, and the notes have already put in this particular uh, website, and this particular link. You can download the notes of module 2, module 1. You can start reading, and it is better you write down and start reading. So that's my humble instructions. That's all for today's class. Thank you.